So this question here, what it's focusing on is scatter plots and straight lines and lines of best fits within the scatter plots themselves. So what it's got is it's got a scatter graph here which displays data from a workplace, and it's a sample of salaries versus time worked at a company. Now, a couple of things this question wants us to do. Firstly, it wants us to find the equation of the line of best fit drawn in terms of P and T. So it's giving you the line of best fit there. And then it wants us to use this equation to evaluate some information that it's giving us. Now, we're going to work through this systematically, part A then part B. And there's a few things we need to remember as we go. But the most fundamental thing we have to remember as we go is it wants the equation of a line. Now, all the other stuff that's there, all the information, the bits about what it represents, the salary and samples of employees over time, what the relationship is, etc. They're all things to think about and remember with the question. But the fundamental thing that you need to make sure you remember is that it wants the equation of a line. It's not asked for any more than that for part A. It just wants the equation of the line. Now, it does say in terms of P and T. And that's something we take into account as we work through it. But the fundamental skills it's after are the equation of a line. Now remember, to get the equation of a line, we want it in the format, so this is part A, of y equals mx plus c. However, it does say in terms of P and T, and if you look at the axes, your x-axis corresponds to the T, your y-axis corresponds to the P. So rather than y equals mx plus c, we actually have to think about it in terms of P equals mt plus c. So we have to think about it in terms of that for this one, just for a slight difference. Now calculating the gradient and calculating the y-intercept, or the rest of the equation, none of that changes. We still use the same techniques that we would before. The difference is coming in the final answer with just different letters used. So the formula for the gradient, y2 minus y1 equals x2 minus x1, is still going to hold. We just need to identify points. Now we've got 2 points on the graph that we can use, this one and this one. And we know we can use them because we can see and we're told that the line goes exactly through them. We can't estimate, so if we can't get it exact, we can't use a coordinate. So for example, if it gave me a coordinate here, I could get the right time worked, but I would have to estimate the salary. So I can't do that. We're not allowed to estimate it. But these ones here, this coordinate down here and the coordinate up the top, they are both exactly on the crossed lines, exactly on the line we're using, so we can use that information. Now we need to figure out the coordinates. Well, this one here is at 5,20,000 in the context that we're working with, and this one along here is at 25,50,000. So we're going to be working with those numbers for this one. Now, as I've said, formula for the gradient doesn't change. So in this case, what we're going to do is we're going to do 50,000, take away 20,000, and then it's going to be divided by 25, take away 5. So 50,000 take away 20,000 gives me 30,000 there. And then 25 take away 5 gives me 20. So if I do 30,000 divided by 20, I end up getting 1,500. So that's going to be the gradient of the line. You might look at it and think, geez, that's a big gradient, that can't be right. But you've got to remember, in the context of the question, that could be right. All right, in the context of the question, the gradient could be that. And given the way it's going up, then yeah, I would assume it is. What we then have to do is figure out the plus c part of it. But remember, what we're able to do is take this equation and write it as P equals 1,500 T plus C, and use one of those 2 points to substitute in there for P and T, and then figure out what we're wanting from that. So if I take the easier of the 2 points, which is the lower one, the 5,20,000, what I'm able to say is that 20,000 is equal to 1,500 times 5 plus whatever the value of C is. So I can then say, fine, so C plus, well, 5 times the 1,500s, 7,500 here, is equal to the 20,000 from that. So from that, I can say that C is equal to 12,500. So now that I know that, I can express my entire straight line here. This time though, like it says, in terms of P and T. So I know then that P is going to equal 1,500T plus 12,500. So that there is the equation of my straight line in the context of this question. Yes, the numbers are bigger, but again, remember, we're looking at context here. Look at the salary numbers that are there, and it seems pretty reasonable. Then part B, what it's saying is to use this equation that I've got and estimate the salary of an employee who's worked for the business for 8 years. So in this case, for the working for the business for 8 years, I have to remember then that that means that T is equal to 8. So what I have to do is take T equal to 8, substitute it into the equation, and see what I get out. So in this case, what I'm going to get is P is equal to 1,500 times that by 8 plus 12,500. So putting these together and calculating it, what I can say is that the person's pay would be 1,500 times 8, that's 12,000, plus the 12,500, 24,500 pounds. Now remember the units in the context of the question. The pay is 24,500 pounds. Include all of that in with it when you do it. Now for this question here, you get 3 marks for part A, you get 1 mark for finding the appropriate gradient, you get your second mark for starting to substitute in to find C and getting the value of 12,500, and your third mark comes from expressing the full equation as they would expect it, in terms of P and T as well. If you use Y and X at this case, you will not get that third mark. You have to remember, if it gives you a context and it gives you variables to use, you must use them. And then part B is just worth a single mark, and that's for just getting your final solution for that. Now this question here, there's a lot of words there, so it could look a bit confusing, it could look a bit more complex and complicated than it actually is. Remember, it's our job to extract the information, extract the key points and the key bits of data that we're after, and then use them appropriately. If you're able to do that, what you're able to see is this question here is nothing more than a straight line question, which we've covered plenty of previously. Yeah, it's just working with straight lines, so it's just working with gradients, y-intercepts, and then substituting into a formula, skills from previous years as well. So it brings in all of those. So if you can remember those skills and you're able to extract the information and hark back to those skills from previous years, you will manage a question like this no problem, and you'll think it's very, very straightforward. It's easy peasy, lemon squeezy.